Welcome back. This will be the continuation on how to create input for the cook model. And in the last session we looked to how to create a PDF file. Now we should be more specific and look to how you could use this file as an input or as a driving variable file for the cook model. So we will look to this by looking to the file we just created before, coming from the Monir examples of the peat inversion soils. And as you may remember, we created one file that contained 5 variables. Those variables are the 5 variables that are required for running the model. But they are not correct. There are some problems related to those files. And one problem is that the name is not correct, because they need to be named so they can be identified. And also there are no units here, but we can guess might be what are the units, or we can ask the guy that have delivered those files, Monir. But I can quickly say that when I look to this, I can of course use the min and max value to make my guess. This is hourly values during 1 full month in September 2023. And max 511 for this instråling, that is global radiation. Sounds like watts per square meter. Luftfuktighet beneath 100 and with the lowest 44. That looks to the relative humidity in percentage, and that's correct. Between 1 and 24 degrees looks like Celsius. That's correct. And wind speed also looks reasonable and correct, but precipitation is not correct, because precipitation is millimeter per hour here, and the units that are required for the cook model, they are a little bit different, and some people may feel that they are special, because we require joule per square meter and day, and precipitation also millimeter per day. Note, always per day, independent of period. So if you have data that are hourly or per minute or per day, it doesn't matter. It is the intensity that we should have, not the amount. And we always have per day, and per day is the time unit base of the whole model. So that could be good to understand from the very beginning, and then you understand why we are adapting to this format. Okay, if we have created one file now called location3.bin, we could modify that by using the tools inside the cook model frame. And we are now looking to the main file view. Besides that, we have a number of other tabs that are representing different operations with those particular data. And to the very right you have change description. Actually I will go for that to test with, because this is the place where we can actually give new information on these names, and we can also apply the units. And there are 2 ways to do this. One way is just to type. I can type this global radiation, and then I have to spell it correctly so it will be correctly identified. But I can also select between names that are available. So then I will say in the list of names, I probably have, yes, I have global radiation. And if I click to that, immediately also a unit popped up, joules per square meter a day. If I go to this next, that is the relative humidity, we can also check for that, and then I find humidity. And then we see that that's in percentage. And then we have Lufttemperatur, that's the air temperature. We look for that as temperature, and immediately we see a Celsius. And then we look for this wind speed. We have also a wind speed here, and that's meter per second. And then finally we have the precipitation. And when we look for that, it comes here, then it is millimeter per day. Okay, then we could apply those as names. And then you see we are replacing the names here, and I apply also the units, and they are here. Now we have the identification of the units correct, and also the identification of the names. But still, we haven't converted the values. So the values are still the same as before. And if I would like to do so, then I move to this change data. And in the change data, you could actually see the exact dates and exact values for each of those time points for or 5 different variables. Now you could say that we can do something similar. We can start to type in new values if we would like to have a new value. But that would be very tedious and take long time. But we could also visit the header. And now I visit the header of global radiation. And then it said right click to see options, to select options. And I right click here, and then I now can replace this existing variable. And if I replace it, then I can replace it by a substitute that is a reasonable substitute for this. Oh, now I have to adapt my viewing here. Sorry. Yeah, now you could see this new window that disappeared for a while, but now you have it. And this window gives us different options for how to do various operations. And most of those are very simple, quick fixes that are required many times when you would like to make some smaller changes. But the one that is most obvious used is this scaling, and then you could scale by using another transformation here by a simple linear equation. So I have an intercept of 0, and then I multiply with the number of seconds per day, 86,400. That's it. And then I go to this OK, and when I do so, we will see that all the values are adjusted here. And then I do the same for the precipitation. I replace that number 5, and then I would like to scale with another factor, not 86,000 but with 24, the number of hours per day. And we do so, and we see we got those values rescaled as well. This is now both changed values and changed description. To make sure that we also save those, I will click this Save Modified File. And if I do so, we know that those have been stored in the systems, and we have been overwriting the previous. So this can be drastic, of course, if you do mistake, but then you can also use other techniques to replace the values or going back. Now I go back to this main file view, and we could re-examine the data. And you may see that this global radiation is still shown, but now the units are different. So that looks great again. And I would like to quickly examine also the humidity. That looks nice. The temperature also looks nice. Wind speed, yeah, why not? And precipitation. This is Norway, and when it said 100 millimeter per day or 150 millimeter per day, you should remember that it's not raining the whole day, but Norway is a rainy country in many regions, including this one. So we have something that I think is a realistic input for starting the model. And I will end this by taking the opportunity to just say that those floating screens can be useful if you would like to see your information in another style. So we have 5 variables, and if we would like to have 1 variables per one plot per variable, then I can take 5 variables like this by clicking on this X plus, and then I click those and I get 5 for each like that. That you get another overview. And you could also reorganize it, so for instance you could take 2 in I and then you replace this so you have 3, and then you see them together. There are many ways to viewing those files and information, and we will not focus too much on this now because we would like to take the next step of using this as an input for running the model. Actually, I think I will close this bin file now, and I will look to what we have in our directory, and then you see that we have this location number 3, 5 still. We did not change the name, but we changed the content of it. And now I would like to look for an XLM file that is the input for the document of the COP model. And I would like to have a template from something that have been used before. And my suggestion is that you could do this by picking up another simulation that have been doing something similar, just to check that those driving variables that we just have created will be useful also for any simulation that will use the same inputs. And then I go to the sample directory, and then I will find in the sample directory an evaporation XML file that has been used to demonstrate the evaporation, but in this case using a file that is climate bin. And if we look to that, we can see here we have temperature, vapor pressure, wind speed and precipitation. So it is a little bit similar, but not exactly the same. But anyway, it's something that should be consistent with what we had before. What I will now do is that I will open this XML file, that is the simulation document that have been using that file, and we can see that if we look to model files, because model file we have a meteorological data called climate. Okay, now this was the previous use, but now we would like to have a new version that should use the new climate file. And to do so, I will create a copy of the document. And then I will actually here just save it as another name, because now I would like to use this for the peat inversion application. So we call this peat and inversion, and then we save that, and then we can actually, we could have continued now, but we can also just exit this, because this peat inversion was now created in a folder that was the base for this evaporation. We can delete this extra file evaporation 656, and then we take the one peat inversion and we copy that, and we go to our peat inversion site, and then we paste it into here. Oh, sorry, I was not clicking, so I have to go back to now I think I have clicked correctly, and now I make a Control V and we have it. Okay, so now we can try to open this. As to open an XML file, you just click on it, double click, and it will be open now but in another position. And this is a document that is prepared for running. So we are close to the possibility to check with the new climate file, but we have to tell this XML file that it should look to the new climate file that was called location 3. Okay, we go to the model file tab, and we look that this file is still asking for a climate bin file, but no information for that because it does not exist in this folder. I right click, I select the new PD file, and then we see that now my browser is pointing to Evapo, but then I will go back to my peat inversion, and then I find this location 3, and then we click to open that, and then we notice that it was filled in with information, and if I click on it I also see that this information looks like the file we had before. So this is promising. I think we should manage to do so, but if we should run the model, then there are more things to adjust. First of all, you may remember that we did not have, for instance, humidity as percentage in the previous. We had a type of vapor pressure. And the model will not understand this if we are not checking also the settings. And the settings will be in the switches. And the switches are in the different groups. And if I go to meteorological data, we can, for instance, start with this, and then we see something called vapor air input, read as pressure first position. We should not use this as pressure. We should use this as a relative humidity. And the relative humidity is actually identified by a hum-rel input switch, and now it is said to be generated by parameters. That means that we could set the value by a parameter, but we don't want that. We want it to be read from a PD file, because that's what we have defined. So let's check now. We have another cloud input, before, that should not be read from a PDF file. That should be estimated from sunshine. And the sunshine should be a global radiation. And here it said RAD globe input estimated, because it was estimated from cloudiness. But now it will be the opposite. Now we read the global radiation from the PDF file, and we will estimate also the cloud input from sunshine. I think that's all. Let's see here now. We have the wind speed is red, and air temperature is red, global radiation is red, precipitation and relative humidity. Yes, that makes 5. If we now click on make a single run, then the model run it for the period that we had in the previous XML file, and now it said 84. Actually, we have to modify this to be 2023, and it should be in September, and it should go to the end of September. We can say that it should go to 2023 and 1st of October 00. That should be the period. If we set another period, then it will not find any information, because it will search in the input file between the start and end date as specified. Another important setting is that inputs have a resolution, and here it is said that it is daily mean values, because that was used in the previous. But here we could now select another resolution, and we happen to have hourly information. Then we have also output interval. Now it says it will store an output every day. I would like to look to the outputs every 60 minutes, since we have inputs that are every 60 minutes. It's also saying that we have 32 iterations per day. That might have been a good choice when we had, an hourly. But when we have something that is 24 hours per day, it should be a multiplier of 24. I suggest that we have 48. This number of iterations can be a long story, because that's the time step that is used for all the iteration, all the calculations. And we could put a comment here saying that trying to adapt to peat inversion. Okay, now we have changed the time. We have specified about the outputs. We had a number of parameters. We had a number of tables with a lot of information from the previous runs. But we disregard this, because now our only interest is to make sure that we could read this climate file, and that we could provide an output also based on the same parameter as we had in the XML files before, but using the new climate file. Okay, I think that should be enough. And if we think it's enough, then we click on this make single run. And it said that it starts to run, and now it said it's complete single run. Click to continue. And then we click here on the run info, and then we see that it changed. So now it said completed single run normal document. Now we cannot do any changes, but now we can look to the outputs. And then I click on the output tab, and then I say that some are empty, no information, but many others are filled with data. So we can look to something like, for instance, temperature. And then we can see, I will modify this now, so I will see it more clearly, that we have simulated temperature, and it's temperature in different layers. So they are quickly damped. But this says that this is probably a reasonable representation of the soil profile. But the thing we really would like to check is actually the meteorological data. And I will just re-click now. If you get this with missing values, then I think we can get rid of that. No, we can't. Actually, this is those that were not selected, so we have not a very complete representation of the file in our input. But we can click on, for instance, temperature air, because that exists. But you see, we have new data showing, for instance, potential transpiration. So that's empty. And we have data for some others, wind speed, yeah. And I think that looks like the one we had before. Precipitation, nothing, okay. This was not so good. Then we should just make a new copy. We go to the output variables, we go to the meteorological data, and then we select others. So we could select global radiation, humidity, relative, potential transpiration, and precipitation, and of course also this air temperature. And then we just make a new run. And then we could go to this outputs again, and now we see that still this V source is not filled, but here we had at least precipitation. We have one precipitation called measured and another called corrected, because the model have a procedure to adjust the precipitation to be correct or more correct than what has been measured. And humidity and global radiation looks nice. Well, I think we have been successful to create something that was just the input, and we have the driving variable files. So thanks for listening to this so far. But if you would like to do something more sophisticated, we should also make use of the files that we have for calibration or validation. They are called validation in the model interface. Some people, they don't like this validation, but we still have used that, so we continue to use that, even that you from a philosophical point of view can be a little bit doubtful to what extent this is validation or what it is. But we will forget about this, and I will say thanks for listening so far, and then you could look forward if you want to look to the next.